Good morning, everyone. I hope you're having a great Tuesday and that everything is going well for you this morning and that you're managing to stay with the schoolwork even though you're at home. But just to, kind of get you going this morning, we have our chapter 2 lesson. Now, we're already moving into chapter 2. Hopefully, you took your chapter 1 quiz that I posted. Remember, it's open notes and open book. Basically, anything I've posted on Google Classroom is fair game to use on it. So, it's 10 questions, shouldn't be a big deal. But anyway, we're going to move on to chapter 2, which is talking about the earth and everything that, is associated with it. So, previous chapter, we talked about geographers and what they study. What is geography in general? Now we're going to start kind of setting up like the planet and all the different forces that helped create and shape both the planet itself and civilization as it flourished through it. But, just a little geography literacy here. We have the Earth is one of, like most planets, the Earth has a moon. Now, many planets have more than one, like Mars has two, Jupiter has many. So really, the Earth having one is kind of unusual, but it actually is a big deal because with the moon, it actually helps create things like tides and creates like a center of gravity for the Earth, because that's all the moon is a satellite around the Earth that is locked in our gravity. Now, the words moon and month actually come from the same Latin word. So we actually use the cycle of the moon around the world to create that, I guess, monthly cycle that we use. Like the relative positions of the Earth, the moon, the sun make the sun and moon appear to be a different shape every night. So, having some nights where it looks like a little like crescent, a half circle, like an ellipse, or even like a fully formed full moon. And then sometimes it looks like it's not even there at all, when really that's just the shadows covering it. So really the moon is, guides a lot of the Earth and its like planetary forces. But, this is probably going to be a little bit of review for most of you, that we have the solar system, which is our sun at the center of our solar system. It has such a strong force of gravity that all of the planets, asteroids, moons, all revolve around it. And luckily for us, I guess you could say that the Earth is just a perfect distance away for life to sustain, but not far enough to where where life couldn't survive. So we're kind of in that perfect sweet spot. But we revolve around the sun, so does every other planet, and each one has its own orbit. Now we have the other planets, which are our neighbors in space. They're the largest objects that orbit the sun. We also have, asteroids and stuff, but they're significantly smaller than most planets. And while this is where it gets a little complicated, because while we have, really, it's more like 8 planets and a planetoid, which when I was your age, Pluto was a planet. And like literally it was. We were taught, that there were 9 planets and Pluto was the 9th. But now it's over the years, it's kind of undergone a change of identity, in that it used to be a planet, then it became more like a moon, and then it became what's known as a planetoid, which is not quite a moon, but not quite a planet either. So it's in this weird, doesn't know what it is phase anymore. Okay. And then, of course, there are some of the planets that have one or more moons. As I said, like we have the Earth with R1, Mars has 2, so on and so forth. Now, each planet has its own makeup. Mercury, Venus, Earth, and Mars are known as the terrestrial planets because they are solid rocky crusts. They're built up, like they're made out of rock. Whereas the gas giant planets, Jupiter, Saturn, Uranus, and Neptune, those are the planets that they're gassy. They don't have, like, there's no solid land that we're aware of, but they're held together by a strong center of gravity that holds all these gases together. They're much more gaseous, less dense. So while we could probably, while we wouldn't get crushed by their gravity necessarily, it would actually be very difficult to go to most of them because they are, I I guess you could say, they're usually hotter or have much more, like there's no oxygen, no life-sustaining anything there. And then, of course, there's Pluto, which is just like a ball of ice and rock. So it's not terrestrial in that it doesn't have a solid rocky crust. It's kind of just like this weird mixture of ice and rock. Again, planetoid, not really a planet. And just to give you kind of an idea of what Jupiter's, like that's probably, Jupiter and Saturn are probably the two most famous. In that Jupiter's the largest. It has, like the giant red spot, which is, a massive hurricane-like storm that's been, going for millions of years. Probably going to continue going all through at least our lifetimes. But really, the Jupiter is a planet made up of different gases. And as you can see here, we have like metallic hydrogen, which is a phase of hydrogen in which it behaves as an electrical conductor, meaning that it can conduct electricity. This phase was predicted theoretically in 1935, but had not been reliably produced in a laboratory due to the requirement of such high pressures. I mean, we're talking like nothing, like things that are very unlikely that we'll ever be able to like build. And under these pressures, hydrogen might exist as a liquid rather than a solid. However, again, it's very hard to recreate that. But as you can see, it has different layers. You have this first layer, which is a layer composed of hydrogen and helium. Then the second layer is composed of metallic hydrogen. Then there's a core that's made of rock, metallic hydrogen, and helium. And then on the outside, it's hydrogen and helium in a gas state. You notice there's one word that's not mentioned, and that's oxygen. So it would be very difficult for us to survive there without some sort of like space apparatus. But that would also require us to have the technology to get there, and that's probably not going to happen in our lifetimes. Then there's other pieces like asteroids, comets, meteoroids, which are smaller objects that, revolve around the sun. Asteroids are small, irregularly shaped, planet-like objects. They're much larger than our normal, I guess you could say, planets, but they're usually smaller than a moon, but they're much bigger than, say, a comet or a meteor. And then comets are icy dust particles and frozen gases. And what makes them kind of unusual is that they actually revolve in an orbit as well. This is why I say Halley's Comet, probably the most famous, always crosses paths with the Earth about every 75 years because it's in a continual orbit. And then there's meteoroids, which are chunks of space debris, rock, iron, that, fly around. And if they ever come into Earth's atmosphere, they will burn and become meteorites if they land. And if they don't land and they burn up, then they're just meteors. Okay. Now, the thing is, the Earth is actually the largest of the inner planets. Its diameter at the equator is larger than the diameter from pole to pole. So while we're a sphere, we're more oval than an actual circle. Okay. The Earth is built up mostly of about 70% water with 30% land, but most of that water is undrinkable. It's all mostly salt water from the oceans. Our atmosphere is about 78% nitrogen, 21% oxygen, and about 1% other gases. So just to kind of tell you, like actual oxygen, pure oxygen is typically not good for people. We typically need to have a mixture of nitrogen and oxygen to survive. So yes, we rely on oxygen, but really it's that combination of gases. And then there's, other gases like argon, hydrogen, etc. Now, to kind of give you a setup here, like typically we have different type of spheres like that we see the Earth revolved around. We've got the atmosphere, the biosphere. So the atmosphere is like our gas and anything that we breathe in, and also protects the Earth from UV rays, from the sun's rays. The biosphere is where life is, the hydrosphere, water. The lithosphere is the crust, the land, and all of that. And the cryosphere is anything ice related. So that would be like around the poles, North Pole and Antarctica. We also have different landforms. So these are physical features of particular shapes and elevations. We have continents, mountains, hills, plateaus, valleys, plains. Those are the common ones. And where you live is going to determine which, landforms are going to be the most dominant around you. And then there's the part of the continent that extends underwater. This is the continental shelf. So when the surface, basically where beaches happen, like, and that goes out up to a certain distance. It's called the continental shelf until you essentially reach the ocean. So, like the Western Atlantic, you can actually see the continental shelf around the continents. So the green area is where the continents are, and the light blue is your continental shelf. You can see some of these actually extend out a pretty good ways, especially down here in the Gulf. Now, this is also another continental shelf around Japan, but just to give you an idea, like where these will kind of like fall off, you have the Mariana Trench. That's the deepest point on the Earth. Challenger Deep being the deepest spot on Earth. So around these islands, the continental shelves don't extend as far, but when you get towards the larger pieces of land, you can see where the continental shelves extend further. All right, well, that's the end of the section. I hope you might have gathered something a little bit from this today. Remember to take your quiz, and if you have any questions, feel free to email me at todd.johnson@bosierschools.org. And I hope you have a great rest of your Tuesday, and I will talk to you tomorrow. Thank you.